So how do you solve the question number 7 using, the standard normal distribution? Like, how do you solve such questions under standard normal distribution? Number one, remember that the questions that you had from your quiz, there were kind of a question where the z value was already being given, okay? You'd be given the value whereby you find the probability where maybe z is less, that was the first one, less or equal to 3.10. The other one for the probability where z was less or equal to what? Negative 0.27, like that time. So this kind of questioning is where the z value is already calculated. But for this question, you still need to calculate this z value, okay? These z values need to be calculated. So how do you go about it? How do you calculate for the z value? The z value shall be calculated as the xz bar minus, not the x bar, sorry, x minus the mu all over the standard what? Standard deviation. So the idea behind calculating the z value is just to ensure that we convert these numbers. Remember, these numbers are so big, you can't have the probability that is 120. Okay, you are asked to find the probabilities. The probabilities should always range from 0 to what? To 1, just in between. So how can you do? The first thing that you do is to convert these large numbers using the z-score so that you can just find something, some numbers that are smaller, and then you use the standard normal distribution table to come up with the probabilities. So let's go. This is your x. You will understand, I know. This number here, number 1 is your what? Is your x. What we are trying to do is to convert this 120. Okay. How do you convert? Your x is 120 minus your mu. This is standard. The mean from the population is what? Is 100 over the standard deviation is what? Is 10. Okay. So the z value is what? What is the z value?
2.
Yes. So the z value is what? Is basically 2. You have 2 as the z value. So it means this one is no longer 120 now. It is no longer what? 120, but it is 2. Okay. It's now equivalent to 2. You have really trimmed this. You have reduced this to 2. To z, where z is equal to 2. But how do you go about it? This is not the final answer. It's still above 1. The probability should always range between 0 and what? And 1. So when you look at this data that follows normal distribution, as we are told that this 2 is on the right side. This one is positive. So this is the 2. Our 2 is somewhere here. Okay. So we are going to look for the what? For the area that is greater than what? 2. Area that is greater than what? 2. What is the area that is greater than 2? The area that is greater than 2 is the area that is after 2, right? That's the area that is greater than 2. The way the area under standard normal distribution is same as probability. So how do we do it now? We will still need to convert this to using the standard normal distribution table so that it can be something that is between 0 and 1. So we are going to the table and locate the area that is equivalent to 2.00. You know that 2 is same as 2.00. So we're going to the table and locate this area. Let's go to the standard normal distribution table. The standard normal distribution table that we okay. So all right. So you go to the table, and how do you find the table? Standard normal distribution table. You find it like this. Okay, this minute. So we check where there is this, where the standard normal distribution table is. All right. So it should be statistics. All right. So I show you first the statistical table. We use the one that you had during assignment as the first one, as the first table first. So how do we do it? This is the table that you have, right? You are looking for the area that is equivalent. Hello, the area that is equal to 2.000. Now, when you look at this table that you have during the residentials or during the test, it gives the areas, it gives the what? It gives the areas that are on the right side of this what? This critical value, this 2. So these areas are already after 2. You understand that, right? They are already greater than 2.
Excuse me, sir.
Okay. Yes, sir.
Someone is not muted. You can hear the noise.
Okay.
Is it Mrs. Njovu?
Okay. All right. Thank you. So this table, the way how it is, it already gives the areas that are greater than what? That are greater than 2. You have seen, right? It already gives the areas that are greater than 2. So what you do, since this one is already giving you what you are looking for, because you are looking for the area that is greater than 2, right? The area that is greater than 120. This 120 is same as 2. We have converted it into 2. So I'm looking for the area that is greater than 2. And the area that is greater than 2 is gotten from this table. So how do you get it? You just come to this table where there is 2.0. Here where there is 2. Where 2 meets with what? With 0.00. That's where you find the 2.00. Right? Like this 2 can be broken down as 2.0 plus 0.00. Like this, the top part, this one gives you the 2 decimal places of the number. Then this one, they give you the 1 decimal places of the given number. So you are just looking where you're just looking for the point where these 2 numbers meet, okay? This first part where there is a 1 decimal place plus this part where there are 2 decimal places of the same number, and they meet somewhere here. Is that clear? So your area shall be 0.0228. So this is the area that is greater than what? It is already greater than 2. Did you get that? This area is already greater than 2 because this table is giving us the areas that are greater than what? The critical value. In this respect, our critical value is what? Is 2. So this table is already giving you the area that is after 2. So this is the area that is after 2 that you are looking for. Clear?
Clear,
hello,
sir? Clear.
Okay. If that is clear, yes, ma'am. Yes, sir. Mr. Chituka, your hand is up.
Yes, I just wanted to find out when we find the calculated the Z value. Yes, what guidance can you see or can we get for us to know that this number we found is supposed to have 0.00 or 0.0?
Oh, okay, thank you. Okay, so the idea behind these numbers, the Z value of the Z score should always be expressed in 2 decimal places. Okay, in two decimal places. So if you find a number like 2, you should add that just the two zeros to hold the two decimal places, like so that it can be two decimal places, right? Then if you find, for example, a number like let's say 2.31, right? You can break this down as the other part should have two decimal places, the other one should have one decimal place. So the first one that should have decimal places, one decimal places should be, it shall be 2.3, right? Then the other part will be 0.01. So that once you add 2.3 plus 0.01, you should get this 2.31. Similarly, if you have a number 2.53, this one will be 2.5. Then the one which will be on top, this one, the two decimal places will be 0.03, like that. If you have 1.67, this one shall be 1.6 and what? 0.07. Did you get that?
Yes, thank you.
Okay. Thank you so much. Okay, thank you, sir. So we said that the Z value should always be expressed in two decimal places, because here on top, if you've checked, you have two decimal places, right? And this side you have only one decimal place. So you're looking for where these two numbers are meeting. So what you do, you express every number into two decimal places. For instance, if you have a number like 2.53, this one can be broken down as 2.5, meaning representing this part which has only one decimal places, plus this other part now, the top part, shall be what? 0.03, okay? So that once you add 2.3, like 2.3 or 2.5, sorry, 2.5 plus 0.03, you can still get 2.53. Did you get that?
Oh, yes, I get it.
Okay, thank you. And so you proceed from there. So you have found that you were looking for 2.00, where 2 meets with 00. So it is 2.0 and 0.00. So 2.0 is here, they meet with 00 here. So this area, which is 0.0228, that is the area that is after, because this one, get that it gives the probability to the, it's a right tail probability, like it gives the probabilities to the right of the what? Of the standard distribution norm, or of the critical value that you have, sorry. It gives you the areas that are on the right side of the table that you're given, of the critical value that you're given, or the Z value. Did you get that?
Yes, sir.
Okay. So since
Hello,
the question
sir.
was, yes, sir.
Which question are we doing? Confirm it's question 6.
Question is 7. Question 7 of the question 7 here of your test. The test that you had, question 7.
Okay.
Then A. All right. So that's how you go about that one. But what if you use the other table? Okay. What if you use the other table? The other table. How do you go about using the other table? Why should I teach you all the two tables? It's because I'm not sure of the table that is coming. Okay. Let me show you the other table. Yeah, this one. Have you seen this table? The way how this one is that it gives you all the areas from this side up to the what? Up to Z. Meaning it gives you, it covers, if you write your table like this, and you put your Z here to be 2, right? It means that it covers all this area up to what? Up to 2. All right? So it covers the area up to what? Up to 2. So How do you locate that area that is from here up to here? Remember what you are looking for. You're looking for the area that is greater than 2, right? The area that is this side after 2. How do you find that area? This area first that is greater than this. First, you have to find the area from here up to 2. If you're given this table in an exam. So what you do, number 1, you go where there's 2.00. That's same way how you do it. Where is the 2.00? They meet here, right?
Sir, zoom the photo a bit.
Okay, thank you. Okay, the sir should zoom photo a bit. Again?
Yes.
Should it
Okay,
be wider
that's
than this?
no, just like that.
Okay. So we come where there is 2 point what? 2 meeting with 0.00. You've seen, eh? It is that area, which is 0 point what? 9772. Okay, that is the area. Now you should look at this area. This area is from what? From the negative up to the z value. Our z value is 2. So it is representing this area. So this area is equal to this one, right? But as we are interested in this one, the area that is greater than 2, the area that is greater than 120, or the probability greater than 120. So what do we do?
Subtract from 1.
We subtract from 1 because the total what? The total area from here up to here is what? It's 1. So just say 1 minus this value. What do you get? Should get the same answer, of course. What do you get?
0.0228.
Yes, 0.0228. Have you seen that, right? It is the same answer, right? Just understand the table you are dealing with. The table that you are dealing with, okay? So if you are given a table like this, madam.
Let's see the table. What's written on the on top?
On the top.
Yes.
Okay.
So that
this is what is written on top. If you find it covering like this is a symbol. It shows that it covers the area from here up to Z. You get it, right? But the one that you had, it was like this. It was just shaded on this part, meaning it just covers the area up to what? The right of this. You got that?
Yes, sir.
Yes. So meaning it just gives the alpha values straightforward. All right. Yes, we can go to the second question, isn't it?
Sir, before you go to the other question, may I see the value we found on the last table you've just removed?
Okay. All right, madam. Where is it? Statistical tables. The value that we found, madam, is we said we went to where there is 2.0, right?
2.0.
Where they meet with is 0. It is this one.
Okay.
It was 0.9772. This area,
Then
it covers, yes. So this area covers the region from here up to where? Up to here. So we want this one, the one that is greater, which means we subtract from 1. Did you get that?
Yes, sir. Thank you.
Oh, okay, welcome. Then we go to the other one.
And then, sir,
madam.
My observation, the
Yes.
first score that we calculated, we found 0.228, right?
0.0228.
Okay.
Yes.
That's where I wanted the clarity from.
Oh, okay. All right. Okay. Where is it? Where is test? Business statistics. Okay. The test is here again. So we go to test what? To test less than what? 87.5, right? less than 87.5. So what do you do from here again? The first thing that we do, listen, you'll understand by the time we are done with this one, don't worry. Z is equal to what? X minus mu over the standard deviation, okay? What is your X? Your X is what? 87.5, right? Minus your mean, 100 divided by 10. What is your Z value?
1.25.
1.2 negative. Okay, you have negative 1.25, isn't it? Right? Are we all agreeing that this is our Z score?
Yes.
Okay. If this is our Z score, what we do now, we go again to the table. But before we go to the table, you know how to break this one down, right? Negative 1.2 plus what? 0.05, isn't it? So that once you
Yes.
add them, when you put them together, you have negative 1.25. I told you that break it down, the other part should have only one decimal place, the other one, 2 decimal places. So we are looking for negative 1.25. And there we go. We go again straight to the table. Which table do you want us to go straight? Okay, let's go to all of them so that you can just be conversant with the tables and I'll be okay. Just need to be fine with all the tables and then you'll be okay. Right, statistics. First, starting with the table that the prof gave you. Let's start with this one. Have you seen the way how it shaded, showing you that it just gives you the area, the probability that is to the right of that.
Okay.
Okay.
Go on, this one we just
Okay. So we are looking for what? Negative 1.25, which means negative 1.2 and 0.02 what? Or 0.5, right? Now, one thing that I should underscore is that this area that gives to the right, it is same as that one that gives to the left. The one that gives to the right, these are to the left, these are the same values, but it just has negatives in here. The one that gives to the left, but it's same everything, same way of interpreting. It's only that you use it when you have negatives. Okay, so like in this case, you can just take an absolute value of this. You still get the same answer. Is that clear? Take this to be an absolute value, that as a positive value. Just say 1.2, where 1.2 meets with 0.05. They meet here, right?
yes, sir.
Yes.
Are you following, right? So now, this is the same when here there is still negative, right? It's still the same answer. Therefore, when you picture this from the graph, from a graph that you can make, or from the graph that you can have, or it is something like this, then your value, that is in, what value is that? Negative 1.25 is somewhere here. Okay, so this value that we are finding, where is it? Is it on the left or right side of this Z value? According to what I've just said, concerning the way how you read this table, the area that we are looking for, this one, is it on the left side or on the right? Anybody?
Should be on the right.
Okay, I don't know which one should be all right. I
It's
might be
on
arguing. Can't you
It's on the
operate?
left side.
Yes, so this area is this side, right? This area is this side. Okay, I've said that this one gives the areas after the critical value. That's what I've said. The areas after the like, yeah, hope you are getting what I'm trying to say. Yeah. So this area 0.1056 is for this area, the area that is less than what? This area is less than this, isn't it?
Hello, sir.
Hello.
Hello.
Yes, sir.
Yes, sir. I've got a quick question.
Yes, sir.
On the 0.05. Confirm if
Yes,
we
sir.
add 0.05 to 1.25, we are going to get the same answer. I don't know how the 0.05 came up. Maybe just a quick one. I'll catch up.
Okay, you said when you add the
0.05 to 1.25.
when you add 1 point, you just say 1.2, not 1.25. 1.2 plus 0.05. You get it?
Oh, okay. Oh, okay. Okay.
Yeah.
So the first one should be to 1 decimal place.
Yes, the first one 1 decimal place, then the other one 2 decimal places.
Okay, thank you so much.
All right, you're welcome. So this area is less than what? It's less than 1.25. You understand that, right? And we are, from the question, we are looking for the area that is less than what? For the area, the probability that is less than this value, isn't it?
Yes.
Yes. So this is the area that is less than this value. That is on the left. To be less, it means to be on the left side. I know somebody, if there is 0 here, if you can write it as negative 1.02, you can start thinking that this is less than this. But what you should understand that this number here is greater than negative 1.25, isn't it?
Yes.
It is greater because as you move to the right, you remember the number line, you know, the number line things, everything that is on the right is great, on the right. Okay. Are we fine with this?
Yes, sir.
Okay. If we are fine, let me show you how you can find the solution now using the other table. Remember that the other table will give you the area, this one that I'll shade, will just give you the cumulative area, or the area from, I would say, this is negative 1.25, or this area, right? It gives you the cumulative area, the area before, or the area just up to the critical value. So let's go to that one. But as we are looking for the area before, this one, that is less. So this one will give you the area that is on the right side, like everything. So check how it is done. You go to the table, fast forward. You go to the table, how is it labeled? The table, thank you. Is it the one? No, sir, it's not the one. Can you go to the other one, you are, sir? Where is it, you are, sir? Statistical tables, it's here. Okay, you've seen it. It's here. We are looking for 1.25, isn't it? We are looking for 1.25, where there is 1.2 and where there is 0.05, where they meet. 1.2, 1.2. Okay, 1.2.
It's 0.8944.
Have you seen where they meet, eh? You have seen this area? Yes, sir, we have seen it. So this area, it covers all the area from what? This is 2.5. All this area to the right, okay? It covers the area that is greater than this value. But the question, in our question, we are not asking to find the area that is greater than 87.5, isn't it? So we will not look for the area, for this area that is on the right. right? We are asking to find the area that is less. And the area that is less is this area that is just before this what? This critical value, this area. How can we find this area if we know this one as 0. What? What is it? 0.8944. How can we find this other part? That is the area that we are looking for.
We subtract from it.
Subtract from 1.
Yeah, what do we get?
We get the same answer. 0 minus 0.1056.
Sorry?
Minus 0.1056.
0.10 what?
0.56.
56. Have you seen that you get the same answer? Eh?
Yes, sir.
Yes, it's just the same table. Yeah, obviously, if you have been even following in the recordings, you will understand that I'm repeating the same things now so that you can remember them. We can go to...
Which
Yes.
values did we subtract there? I don't
Sorry?
know, somehow I'm missing it. I'm saying, which values did we subtract?
From the previous table you have just had?
Yes, just now for us to find the value of that area. Which two
Okay.
values did we subtract? Where there was the negative 1.25.
1.25, you say 1.2 plus what? 0.05, fine. Where they meet 1.2 and 0.05, it is here, right? This is the area. Now this area, it covers all the area from where? It covers all the area up to the critical value. Since we are moving to the left in the negative direction, it means that your critical value negative 1.25 is here. It covers all this area. So this area is equal to that, right? So as we are interested in this area, that is less than this number. Okay, this area where I have put the arrow. So how do you find this area if you already know this part, this larger part, this one? You already know this one as 0. What? 8944. But how can you find this other one? Obviously, we know that the total of all the area under the curve is 1, right? The total of all the area or the probability under the curve is 1. So you just say 1 minus this one, right? Minus this value, you should get that. Hope that helps.
Yes, I think.
Sir,
Madam.
so using the normal distribution table, the one which was in the assignment, you found 1056. Did you subtract anything or you just got the 1056?
No, we didn't subtract anything because that one was giving us the direct values. It was already giving us the values that are less than the critical value. It was giving us the area that is in the extremes already. You got it?
Oh, okay.
See you, man.
Yes, sir.
All right, progress. Okay, Basa, you can move on. What is the other figure giving us? Oh, okay, the other question, you can just read it so that before we move out of the table. It is between what? What values are there?
93 and 116.
93 and what? And the 116. What do? We convert again these two numbers. You know how you convert. So you say 93 minus what? 100 divided by 10, isn't it? Hello?
Yes, sir.
We're still doing the same conversions. What do you get as your Z value?
Yeah.
Minus 0.7.
Minus 0.7, isn't it? 70. Then what about this one? 116 minus 100 divided by 10. What do you get?
1.6.
1.60.
6.
Okay. Is that clear?
Clear, sir.
Hello.
Clear.
Clear, sir.
So now, let's go to the table and find the areas. We are going, let's use that one you had in your assignment, not your assignment, your exam, your test. Obviously, the prof can repeat the same. I mean, not the same question, please. I mean the same table, so that I cannot be crucified tomorrow. But don't worry, everything will be fine, and it's easy. And just don't panic. Okay. We're good to go. Yes, sir. We are good to go. And so this is how you go about it. We are looking for where there's 0. What? I said when you are dealing with the one that gives to the right tails, forget about the negatives. You get just get the absolute values if you are dealing with the right tails. So 0.70. How do you break this down? It shall be 0.7 plus 0.00, isn't it?
Yes.
Yes, sir.
Yes. Let me give you just a, it's like this. Negative 0.70 is here, and 1.6 is here, So this area that we are going to find for 0.70, it is to the right of this. That's what we've said. Not to the right, sorry. It is before the critical value. You get it, eh? Or it is after the critical value to the left. So we go to 0.7 and 00 where they meet, isn't it? Right?
Yes.
Yes. So this area is equivalent to this area, right? 0.2420. What about this other one? You go again where there's 1.6. The area that will find it is here. It will be on the right side. 1.6. It is not shown. Okay, let me show it. 1.6. Hello. 1.600.
0.0548.
0.0. Remember,
Oh,
these
hey.
values are given as a point. So just know that before the point there is 0. Okay. 0.0548. Now, the question is asking you to find the area that is in between. That is here. You know already the area that is in these other sides, right? But you know the total area under the cave is 1. So what can you do from here? An idea? How do you find this red region?
You add.
Okay, so you can say 1 minus what? 0.2420 plus what? Plus this other one, 9. 0.5. Okay. 0.0548. Right? Like that. What do you get as the area that is in between? Hello. Hello.
Yes, sir.
What do we get?
24.
Negative?
Negative 24.
No. Like 1 minus this
Let
number.
me check again.
Yes.
No, I did everything at once.
Oh yeah, probably, but even, oh,
So it's 0.7032.
0.7032.
7032. Yes.
Do we all agree?
I found something different, sir. I'm finding 0.921.
It's 0.7032.
Okay,
It is
obvious,
correct. That is correct.
obviously the majority should win, right? Okay, you can try to redo it again, madam.
Sir, you said we
Just look at
subtract
what I've written. You say 1 minus the sum of these two.
okay.
You got it? Hello.
Yes. Yes, sir, it's 0.7.
So,
Okay, so basically this is the area that is in between, all right? Because you have already subtracted these areas that are in the extremes. So you have removed them. So what you remain in between, that's the area that is in the clear.
Yes, sir.
sir.
Yes, sir. Is that a question? Okay.
Sir, I'm not clear, sir. Yeah, what are the
Yes.
figures? I'm
Sorry?
behind. I'm not clear. What are the figures behind?
You
I'm
say
adding
1 minus 0 point what? What are those numbers? I've already raised them. You know, when I press the button, everything goes. I don't know.
0.2420.
20 plus
0.0548.
Like this, madam. If you want, you can say 1 minus 0.2420 minus 0.0548. You would have distributed the negative. It should give you the same answer. What do you get?
0.7032.
Yes, that's what we found. You're fine now?
I'm fine, sir.
Okay. We are good to go. Yes, sir, we are good to go. And so we go to the quiz. This was from the test, but let's check from the quiz how it came. We just want to make sure that you're okay. Business math quiz. No, not this one, sir. Business math quiz. Business math assignment 1. Should be this one, sir. This one, yes, sir. It is this one. Okay. Have you checked now the way how this one came? Okay. The one that you had in your quiz. With this one, the Z values were already what? Calculated, isn't it? So Z was less or equal to what? 3.10. The other Z was what? Greater or equal to negative 0.27. Then the other one, the Z was what? Was in between. Okay. Was between negative 1.45 and what? 2.60. Otherwise, it's the same way of doing it. It's only that the Z value has now already been calculated. You don't need to calculate it. We go about it. We do it.
Yes, sir, let's do it.
Okay, let's do it. Let's do it. So we're looking for the area that is less than this. Okay, less than that. Going to the table, We got the standard normal distribution table. Let's go to our table. Yeah. And okay. We can still use the full one. We remember that our Z is less, right? So it's less than 3.1, which means is 3.1 is somewhere here, right? Our Z is the area that is this side, right? From 3.1 up to this side. You're following that, right? Which means it's equivalent to this area that we're going to get here direct. So it means once we use this table, we don't need to subtract or do anything. Just get the exact figure, direct figure. So you go where there is 3.1, and where there is 0.00. Where do we find 3.1? I think now you know how to read the table, because the whole conversation is around reading the table. Where is the 3.1? Meeting is 0, here, right? Is it? Hello.
Yes, sir.
This area is representing, according to the diagram above, it means that it's covering the area from where? From here up to this critical value, which is already the area that we are looking for, right? We are looking for the area that is less than the area that is less than this 3.10. So this area is already less than what? 0.99. Is that clear?
Yes, sir.
What if you use that other table, which will give you the area that is on the right? Okay. If you use that one, if you use the other,
So the one I'm using, it's giving me
The one.
0.0010.
yeah, you are using the other one. Look, you should be looking here on top, the way how it is drawn. Okay. Check the way how it is. This one is a full one, like it covers all the area up to the critical value. Then the other one, it just covers the critical, the areas after the critical value, which is the alpha region. Did you get that?
Okay.
If we use that one, the same one that you have, if we use the one you have, this is what you will have. Are you going to have? Okay. It's here. Okay. This is like the one you had, this one.
Yes,
okay.
sir.
So visualize your 3.10 is where? Is here, isn't it? So
Yes.
the area that you are going to get is here, it's on the right. But you are looking for the area that is less, which means this area, okay? So can you look for 3.10? Just know that the area that you find it is on the right side. 3.10 here, right?
Yes, I'm getting
0.0010,
Yes.
isn't it? So
Yes.
just know that this area is this side, but we want this one. According to the question, we want what is less. So you subtract from 1, okay?
From
Just say 1
okay.
minus this. Obviously, you get the same thing, which is 0.9990.
Okay, sir.
You got that?
Yes, sir.
Are we all fine?
Yes.
Yes,
Yeah.
sir.
You should
Sir,
be
I think
fine.
I'm mixed
Yes,
up
madam.
on this one, sir.
Yes.
I'm saying
Where,
I'm
madam?
mixed up. I'm confused on the tables.
The two tables. Hey, where are you mixed up, madam?
I mean, which table to use when you are subtracting from 1 and which table to use to get
Okay.
just that figure.
Okay. What is there is that the reason why we are using, I'll answer the question. The reason why we are using these many tables, like 2 tables, is because we don't know which one we can come in an exam. Okay, they both give the same answers. You still have to get the same answer. So the problem is if you are just used to one, then the other table comes, which means even the questions that you know how to solve, you can get them wrong because you just don't know how to select the answers. So now, answering the question. So madam, once you see, check on top. This one says that it gives the probabilities that are on the right of the Z value, right? On the right, this table. So just know that if your Z value is where 3.10 here, it is here. Just know that the area that you will find, it is on the right side here, okay? Keep that in mind, always. But if you are using the other one, this other table, which covers this area from here, just know that you're getting all the area from this side up to the what? Up to the critical value. So if you're already asked about what is less, we should just get this directed. That's less already. But if you're asking about what is greater now for this one, it means you will need this area. Therefore, if you're using this table, you need to subtract this area from 1 so that you can get this one equivalent to that. You got that?
Yes, sir. Clear
Okay.
now.
We are good?
Good.
Yes,
sir.
sir. We can go. Going to the second one, what does the second question say? Just give me the figure so that we can, at least we can just, negative.
Greater or equal to negative 0.27.
Okay. Greater. Okay, Z is greater or equal to what? Negative 0.27.
0.27.
I told you to take this as an absolute value, right? Take this as an absolute value. So you have 0.27 that you can break down as 0.2 and 0.07, isn't it?
Mm-hmm.
Yes, sir.
So you go where there is 0.2, 0.2 and 0.07 where they meet. Okay, you have seen where they meet. Are you able to see that? This number?
Yes, sir.
Yeah, 0.3936. Okay, 0.3936. Now, when you look at this value, we have to find first the location. Ask yourself, where is it located? Is it after this? Is it on these small, but the extremes, or is in between? You understand, right? So this gives the area the right of the critical value, which is same as to the left of the critical value. Same, right? To the left, it means that there is a negative. To the right, it means that there is a positive, but the values are the same, like the probabilities are the same. The answer will still be the same. So what do you get? This area, it is somewhere here, 39, 36. But the question is asking you which area? The area that is greater, right?
Yes.
They want this area from here up to this side. That's the area that is greater. So what do you do? Hello. Hello.
Subtract from 1.
Yes, subtract from 1. 1 minus 0.3 what? 39, then 36. What do you get?
0.6064.
0.606 what? 64. Basically, that's the area now that is after this point. Are we all fine now? Hello.
Yes, sir.
Sir, let me see the chart on top.
Okay.
Me with this chart, I will.
This one.
It's like there are 3 types.
You've seen it, eh? The one that gives the area that is to the right of the critical value.
This same chart, it's like there are 3 types. Huh?
The only difference between this one, maybe you can have the other one where they are just negatives here, but the values that they give are the same. That's why I said just treat, if you have this one for positive, like in an exam, you will not have all of them. You can only have one. Just know how to use which one are you using. I told you that the one that has got negatives in here is same as this one that has positive, right? Like this one. As long as you find the one that has negatives, you will find that it will be able to like this one. This shaded part will be this side. So they will write that it gives the areas to the left of the Z value. You got that? It's the same, like you give the same answers. Remember, the probabilities are always positive, right?
Yes, sir.
Yes. You're fine?
Yes, sir. I think
Good.
I'll be fine when I see both the charts.
You see both charts?
Confusing.
No, there is this one. You have to see them right in this class. There is no time. There is this one. You have seen this one, eh?
Yes, sir.
Yes. Then we also have got this other one. The standard normal distribution table. Where is it? The statistical table. Statistical table. Also this one. Have you seen it? Right? You've seen the way how they are shaded, right? The way how it is shaded should tell you how much area is covered.
Okay.
All right. Thank you so much. And we can now move on to the other one. The last one was saying what? What was it saying?
Excuse me, sir.
Yes, madam.
The one you are just from doing, the one which is it greater than negative 0.27?
Yes, madam.
Yes, the final answer was 0.3936. I was kicked out a bit.
No, like you subtract that from 1 now, so that you
Okay.
can find the area that is yes. All right, are we good to go?
Yes, sir, we can go.
Yes.
Hello.
Thank you. Yes, sir.
Sir,
yes, sir.
just a comment before we proceed.
Yes.
The list of formulae that professor gave us, it doesn't have the full one. So I think people should be conversant with the right tailed one, where you subtract if you are told to find values between or less.
Okay.
Because on the graphs that the professor gave us, the full one is not there, that one.
Okay.
Yes. Even the example he was giving in class, he was subtracting because he didn't give us the full one.
Oh, he gave you this one? Because this is the one you were using in your test.
Yes, that's the one he gave us.
Oh, okay. All right. Then let's assume that since at least you have ideas about the other one, from now onwards, let me be using this one, right? At least you already have the ideas about that one. I was just trying to mention that in case you're not sure of which one he will bring. Yeah, there are those times when the table that has come, you don't really understand it better. But since you have said you You learned this in class, you are using this one in class, and even in the test, you used this one, then obviously it is the same one that will come. But if something else comes, just remember that I've taught you how to use that something else. So you'll be fine.
Then, sir, sorry to take you back.
Yes.
So maybe just clarify once more on the question, on the one that says is this score less than 3.10?
3.10.
Yes, sir.
Using this one.
Using-
Okay. So we are looking for the area 3.10. We are looking for this area that is less than 3.10. But this table is giving us this area which is on the right, isn't it?
Yes, sir.
Yes. So you just go where there is 3.10. Where is 3.10? 3.10. It's here, right?
Yes, sir.
This area 0.0010 is that side to the right. But as we are interested in this area that is less than, you get right? That is less than this value. So you say 1 minus 0.0010. Did you get that?
Okay.
Yes. What you get is what? 0.999, right?
Yes, sir.
Yes. You're fine now?
I'm fine now, sir.
Okay. All right. Thank you so much for that. We do the other one was saying what? We'll stick to this one where you are subtracting so that you can be more conversant with it. It is what? It was
-1.45.
okay. So we are looking for negative 1.45, and which one? 2.
Should be less or equal to
2.63.
yeah 2.65.
This is your table. Like that. It has got these areas, right? Okay. So you are looking for the area that Z is in between, eh? Meaning Z is here in between this number and that number. So what can we do? Number one, we can find the area here in the right, since we are using this table that gives in the right. Can find this area to the right and also this area. Then we subtract those areas from 1. We should be able to get what remains in between. We can find first for this, madam.
So you just have to subtract 1. You can't add 1.
No, you can't add 1. The probability should always be less. Should always be between 0 and 1. It can't be greater than 1.
Oh, okay.
Okay. All right. So let's go for this one. It will be 2.6 and what? Anyone?
0.03.
0.03. Yes. So you're looking for 2.6 and 2.6 and 0.03. So 2.6 and 0.03. 0.00010203. Is it? 2.6. Let's check on top. 2.6 and no. This is 0.0001001003. Oh, okay. Check that is 33 0.03 there. 2.6 in this line. Yeah. Have you seen where it is?
Yes. 0.0043.
So it is this one, eh? 0. What? 0.043. What about this other one? For this one now, this one you go per negative per 1.1 what? 1.4 and 0.05. 1.4 and 0.05. 0, 0, 0, 1, 0, 2, 0, 3, 0, 4.
0.0735.
Okay. So it will be 0.0
0735.
Okay. So we are looking for the area now that is in between. We have found these areas that are in, like these that are in extremes. But how do you find the area that is in between? Okay. How can you find the area?
You said we subtract
You say 1 minus 0.0735 plus 0.0043, like that. What do you get?
0.308. 0.9308.
0.9308.
0.9
308.
08. It's a big number. Eh? It's a very, very big number. Okay. So like, yeah, so that's what you would use here to find the areas that are in between, the area that is in between. Did you get that?
Yes, sir.
Madam? Hello, is that the question? I think on this one you have misled me. Negative, where they meet with is 0.4. Is it not 0. Okay, this is 0, 0, 0.1, 0.2, 0.3. It should be 0.079, right? 0.049, 0.0749, isn't it? Not following. You're not seeing it.
No, sir, it's fine the way it is. It is fine. It is 0.005.
Oh, it should be 0.005. Oh, okay.
Yes.
Yeah, not
the very
too
one.
Kanshi, you are following. It's well. Any question?
Which one? Which one is that?
This one, madam, the 1.4 and 0.005, like that. This one, we're talking about this one. You okay?
So this will be 0.0735.
Yes.
Okay, plus 0.0043.
Then your answer now, like subtract it from 1. All right. Are we fine now? Okay. So now, sometimes the common words that you, at least now you're fine with greater than or less than. So sometimes words can be used such as at least. You know, at least means greater or equal to I. Then less or equal to is at most. Yes.
Sorry, the answer was 0.9222.
What did you find? I've already erased. I don't like. I'm not sure.
0.9308.
You're finding something different?
Yes, sir. I don't know if it's my calculator or what, but same figures.
Finding the same number that Madam Yvette is finding, 0.922.
Yeah, because that's why I recommend that everyone, at least many people, should be solving at the same time. Because if you only one person gives me the figure, you'll be getting that, okay? So
the correct figure is 0.9222.
Okay, so I said, give me that one was 0.0735 plus what?
Plus 0.00043.
Okay, 0.43 like that. Yes. Can you have some? Is everyone confirming that it's 0.99922?
Yes.
I also found the same.
Yeah, okay. Thank you so much. That's why at least we should be participating, at least a good number of us. Okay, we move on now. So you are fine. I was just saying that the word at least, it means that greater or equal to I. Then at most is less or equal. Did you get that? So sometimes you can find the words being used like, okay, can you find the probability that this is at most? So when you say this is at most, we mean it is less or equal to I. If it is at least, we mean greater or equal to. Is that clear?
Yes, sir.
Okay. If that is clear, then now we can move to hypothesis testing. That question should have come from somewhere. The quiz, was it a quiz or something? Okay, let's check. Hope no one has remained behind water. Everyone is okay. Everyone is fine with what you are doing. Question number B3. Oh, 3B, not B3. 3B. You've seen it? So an investment analyst claims that the average annual return on services in the tourism industry is 12%. You want to test whether the claim is true. You collect a random sample of 36 services in the tourism industry and find that the average annual return is 10%. With a standard deviation of 3%, use a 5% level of significance to test the analyst claim. How do you test this hypothesis? How do you test the claim? So basically there are the main methods that you can actually use. Okay, the first one that you can use is you can use the p-value. Use the p-value method, or the common one is the z-value that you are used with. Let's use the z-value since you are now conversant with the z-value. Okay, the z-value. So now there are two z-values that you will have. The other one will be the calculated z-value, and the other one you just get it from the table. So the calculated z-value is found by saying x minus c, the mu, that's x bar minus mu population mean, or over what? Over the standard deviation divided by the square root of n, where n is the sample size, sigma is the standard deviation, and mu is the population mean, and x bar is the sample mean. So how do you go about it? Let's calculate, let's collect data now. We already know our formula. We need to collect it. Madam.
May you repeat what is n?
N is the sample size. Sample size, the size of the sample.
Okay, then the other one is the standard deviation.
Yes, then the other one is the population mean, and the other one is the sample mean. X bar is the sample mean, mu population mean, sigma standard deviation, and the square root of n, that is the square root of the sample size.
Thank you.
Okay. All right, friends, let's go now. Let's collect data. Okay, let's collect data. The mu is the population mean. What is the population mean? That is same as the average, okay? Like the average. What is the average from the population?
12%.
It is 12%, right? So an industry analyst claims that the average, okay, on average, the annual return on services in the tourism industry is what? Is 12%. So what exists now is that from this proposition, it is said that the 12% is our mu, our population mean. So let's say 0.12 is the what? Is the mu, whereas the n is the sample size. How large is our sample size?
36.
Yeah, 36. And the standard, okay. What is our, population mean?
Our population mean is 10%. Huh?
It's 10.
Yes.
10%, which is 0.10, and our n, oh, that's our n already. Then our sigma, the standard deviation, 0.03, right? 3%. Then what else do we remain with? Alpha, our level of significance. Alpha is what?
5%.
5%, 0.05. Clear?
Clear, sir.
Okay. If that is clear, then you can easily calculate for the z value now. You can calculate for the z value. Just substitute, issue of substituting x bar is 0.10 minus 0.12 all over what? All over 0.03, the standard deviation divided by the square root of the sample size n, which is 36. Did you get that?
Over 0.0.
Yes, sir, sorry, network kicked me out. Where did we get 0.03?
Is the standard deviation, madam. They are saying that the standard deviation is 3%. So, yeah, 3% is same as 0.0. Thank you.
All right.
Okay, what do we get? What do we get next? Hello. It is 4.
Is it 4? Is it 4?
It's 4.
Just 4 or negative 4?
It's just 4.
No, negative 4.
Yeah, negative 4. So.
Okay. We have found what? Negative what? Negative 4 as our z value. So our z, this is our calculated z value as negative what? 4.00, you may like, or negative 4. Is that clear? Are we all fine with the way how you first calculate for the z value? We are talking about calculating first. Hello.
Hello, sir.
Yes. Yes, madam.
Yes, sir. I'm not sure on how to calculate, especially at the bottom. Do you find the square root of 36 first, and then what do you do exactly? I'm not.
Okay, you can still find the square root of 36, which is 6, right? You can say at the bottom, you can say 0.03 divided by 6. Okay. That will give you one number at the bottom. Divide that into 0.02, the one that you get on top, and negative. Then you get the thing. You okay?
Yes, sir. Thank you.
Okay.
Say again.
Are we all fine on? You can say 0.03, right? Divided by the square root of 36, which is 6, isn't it? When you divide the 6 into 0.03, it should give you 0.005. Is it 005 or something? How many zeros?
Yeah, just
Okay.
like that.
Yes. Then you say now, what is the negative 0.10 minus 0.12? It should give you negative 0.02, where you should divide by 0.00 at 5 to get negative 4. You got that?
Yeah.
Did you get it? But
oh, Shani. You're saying first I find the square root of 36.
yeah, which is 6 already, we know that.
Yes. So we say 0.03
divided by 6. So that you can get 0.005, right? The calculator gives you something else. Hello.
Then it's giving me negative 0.015.
How come? Are you talking about the whole thing, or you're just talking about the down part first?
I need the down part. It's even giving me at 5 and then to the power negative 3.
Yes, because the scientific notations, come on. Like
Okay.
5 times 10 to the power negative 3. The assumption,
So
the calculator assumes that you understand the significance figures and the standard forms. You know those standard forms and okay. Okay. It's the same thing, you know those standard forms.
Then I subtract what now? Yes, so I subtract what now?
What you do this one is, it means that the point. Hello?
Maybe let me just help my colleague there. Yeah, so colleague, what it means there, it means that that negative 3 there, it's saying that from the point, we moved 3 steps to find that 5 there. Meaning that if you have to reverse that one now into a number that we can easily interpret, you need to move from 5 there. You go 3 steps, then in between there are zeros, 0.0. I don't know if you get one. It will lead you back to 0.00. If you look at the figure that the SAR has calculated there, it's 0.005. Can you count from the point there? How many steps are there before you reach 5? You find that there are 3. That is the kind of criteria that is there. I don't know if you've gotten the point.
Oh, okay. Thank you.
So the calculator can't just be straightforward to say 0.05 because I was also confused.
So the thing is that the calculator will never give you wrong answers unless you press it wrong. It will give you, it just follows your command. So let's understand how we use calculators.
Okay.
Yes. Okay, we are fine. We are good to go. Now, before we just move on, it's extremely important that you go through, you start using your calculators so that you understand how your calculators work and how they give you the figures. Because, and they avoid borrowing calculators. like those that you don't understand. For example, you don't know where permutations are, you don't know where combinations are. From that calculator, you go, you start, you know, wambo zima, like you just start breaking out, you know, those things. But you know what to do, you just don't know how to use the calculator. Make sure that you take the calculator that you understand very well and how it works. That's fair. Okay, so you can move on now. We have head. Okay, so now that you have found the calculated, yes, madam.
I think when ufunika na marefu nja calculator lero. Because these forms of answers it's giving. Imagine my exam, man.
So the thing is that just make sure that your calculator is just normal, like it's not in standard. It doesn't give you scientific notations, and it is in degrees. Just make sure that you know those settings on the calculator. Just set it. Like every calculator is just okay. Just do the settings, you know. Just do some simple settings.
Okay, degrees up. Because it will give us things you don't understand.
Just find out from the good neighbor, like you. Okay, don't worry about that. I think you should just don't panic about the calculator anyways. It's okay. Yeah, don't worry. Don't worry too much. It will be easy and very straightforward. Find out from the good neighbor. And so how do you calculate the other z value from alpha, from the significance level? So this is how you do it. Now listen. Where is alpha? Alpha is always in the what? In the rejection region, isn't it? Alpha is always in the what? In the rejection region. If you remember very well, this we said is an acceptance region. Yeah, I'm sure there could be some people joining us for the first time. You're hearing me just speaking straightforward. It's because my assumption is that you already have the basics by now. Yeah, otherwise if you are learning, I'm not really teaching, I'm advising you. That's why I'm not entering in details. So don't go in that message that the sir doesn't explain in full. The sir explains in full when, if it is time to explain. But this time around, he's just, he's just revising with you. Okay. So this is the rejection region and the rejection region. Now, here is how it is done. Basa, can you slow a bit here? Yes, I'll slow a bit. So the side is going to slow a bit here. This is how it slows. When you look at this question, the way how it is phrased, there is the first claim that exists, okay? An investment analyst claims that an average annual return on the services in the tourism industry is 12%. So this is what is called the null hypothesis. The null hypothesis states that you believe that the mu is equal to what? To 0.12. When you're forming the alternative hypothesis, you say that alternative hypothesis, your mu is not what? Is not equal to 0.12. Okay, that's how you phrase. So now, if you check, you see that this mu, your alternative hypothesis says that mu is not equal to a given value. It means that that data is symmetrically distributed. So it follows a normal distribution. That is to say, it can be, like the data can be distributed or either to the right or to the left. That is to say, if this mu is not equal to 0.12, it can either be on the right, it can be either greater than that or less than that, meaning on the right or on the left. Okay, having said that, that simply means that if you are to graph this, you can easily depict this from the graph okay, where we say that this data now follows a normal distribution. If it is double-tailed, it follows a normal distribution. So if it follows a normal distribution, it means that this alpha that you are finding, because the alpha is found here and here, right? These are the rejection regions. If you're given that your alpha is 0.05 and it is double-tailed like this one, you will have to divide this by what? By 2. So that you can get what? 0.025. So this side will be 0.025. Even this side you have 0.025. When you add together, you still have the significance level. Are we all fine up to there?
Sir, but how do you know that it's double-tailed?
Yes, that's
Is
the
it
question.
because of the rejection regions?
Thank you very much. How to know that is the double-tailed? You follow the wording in the question. If they say that the mean is a given number, then it means that the null hypothesis, the mu will be equal to a given number. Once you hear that the mu is equal to a given number, then it is a double-tailed, because the alternative hypothesis will be not equal, which will make the data either to fall on the right or left, right?
Mm-hmm.
Did you get that? But if you, okay, what's up? You can explain further. If you find that it says that the average, okay. If you find that, let's say that you find that, what's this? You find that the mu, they say that the mu or the average is more than maybe 12%, okay? It's more than 12%, which means that your null hypothesis will be that mu is what? Is greater or equal to what? It's greater than what? 0.12, because more than means greater than, right? Then if you hear that it is less than, it means that your H naught is less or equal to what? 0.12. Now, if we say that it is more than, what we mean is that this data is distributed to the what? To the right. You get it, right? That's what more than means. Like the data, this mean is supposed to fall to the right of the mu. So that's how you depict this one. So your alpha 0.05 shall not be divided by 2 if it is single-tailed like this one, which is skewed to the right, because you're talking about something greater than I. Now, more than is same as at least I. If you find that they say that it is at least the average or the mean is at least a given number, it means it is greater or equal to that number. Then if we say it is less than or equal to that number, it's same as when we use the at most. You can say it is at most maybe 12%. That is to say that that distribution is, the data distribution is skewed to the left as to the negative. You get it?
Yes, sir.
Hello.
But yes, sir. But then my question would be, in this information we've been given, how do we know that mu is equal to 0.12? Or this is the hypothesis that we're supposed to try to prove?
Because, okay, thank you.
If the
way
is true,
that is there is, it is written here. The question says, an investment analyst claims that the average, which is the mean, in the tourism is means equal, right?
Okay, okay.
Yeah. You got that. Any other question? Or is the questionnaire fine?
It's fine. It's clear, sir. Me understanding language is not one man.
It is him. It is him who asked it. I heard a gentleman asking.
Yes, sir, it's clear.
Oh, okay. Thank you. So what is there is now, since this is double tail, I said we are dividing by what? By 2. When you reach here, it's easier. We are going to the standard normal distribution table and locate, we are going to locate this area, okay? Where it is. This is our alpha. Our alpha now is equal to what? 0.025, 0 if you want. So we're going to locate it from the table. So what do? You got the table, right? Can pass here, man. Okay. So Senate. Pangonte. Yeah, so what is there is, okay, just a minute. No, just trying to do some kind of online class with Senate. What class? Oh, class with these guys are at distance. So they're not meant to keep 19. Yeah. 19. Double chatting. Okay. Okay. All right. All right. Let's go to the table. Let's go to the standard normal distribution table. How many people do we have? Like, which table should we use? Oh, you said that we should be using that one from the lecture. That's what we agreed. Okay. Clear? So we are locating the area 0.0250, isn't it? Can we look for it from here? Where is it located? Are you able to tell us where it is located? Anybody who is able to tell us where it is located? Okay, the area is here, right? Hello. Oh, I'm muted.
Yes, sir.
No, I get
Can
you.
get you, sir.
So you are just looking for this alpha from this table. Since this table is already giving you what? So when you come here, what you do, you move to the left first time. Move to the left. What do you get? You get this figure 1.9, right? Hello. 1.9.
Yes,
then you move upward. You get this decimal, 2 decimal places, which is 0.06. You add, you get 1.9 what? 6, isn't it?
Sammy, I'm lost. Where are you getting these figures?
Okay. So are you fine with the way how we locate this? Like you're just looking for this number from all these numbers, right? The area 0.0250.
Just back up a little bit. How did we get the 0.025?
Oh, it was our alpha, right? Our significance level. It was 0.05. You say since this is a double tailed, we divided it by what? By 2 to get that.
Okay. Okay.
You're fine now?
Fine, sir.
So you're looking for this area from this table.
Okay.
We have located the area. It is here, right? So you move to the left first. When you come to the left, you find that this area is in the line where there is 1.6, isn't it? Hello.
1.9.
Yes, 1.9.
Because happening 0.025. Hello.
He's muted his mic.
I think so.
Oh,
okay.
Hello. Okay. Sorry. I was talking alone. So I was saying that once you locate this area, you just move to the left. It means that this area is in the line where the Z value is 1.6 plus the upward, like you go upward, you get the 2 decimal places to that number. The 2 decimal places are what? 0.06, isn't it?
Yes.
It's up here. It's there. When you add them together, you get what? What do you get?
So is it 1.9 or 1.96?
1.96, isn't it?
Yes. Yes.
Okay, I get it.
Okay.
So I'm behind where you written this, how you are doing this. We are looking for the actual figure, the 0.025 on the chart.
Yes, madam. That's the one that we are looking for. So we are looking for the actual figure. You look for it from all these numbers. You're looking just for that number, from all these numbers. So finally you have found it. It is here, right?
Yes, sir.
When you find it, you move to the left, check the line where it is to the left. You find it is in the line where there is 1.9, isn't it? Then you move upward, you check the 2 decimal places. You find that it is what? 0.6. 0.06. Yes, then you add these numbers. You have that, right? As a critical value.
Oh.
You got it? Yes.
Yes,
so, all right. So hypothesis testing and the what's that standard normal distribution have got a very deeper conversation around this. It's only that maybe, by the way, the videos are long, I'm aware. They are long. So what you do is you speed them up, okay? How do you speed them up? You just listen where you want to. This time around, you are just listening where you want to hear. Like you're looking for something. That's the expectation. Like you're not listening for, you're not listening to the whole video, the whole 2 hours. Probably you don't have that time. Okay. So now, how is it done? This 1.6, it will be this side. Since you are following the negative lines, I can also have a positive one this side. The same thing. Since like your Z value, it was a negative, right? So just make sure that you put this critical value to the negative side. Okay, you're moving towards the negatives. So when you reach here, how to test the claim? You check, is this calculated Z value, Z statistics equal to this critical Z? This one is called the critical what? The critical Z. Is that clear? We call this the critical what? The critical Z. Are they, which one is greater than the other? So you find that this -4 is somewhere here, right? Yes, sir. So you find that it's somewhere here, which is the rejection what? A rejection region. We said that these are rejection regions, right? So in the rejection region, it means that you reject the null hypothesis. What was your null hypothesis? Your null hypothesis was mu is equal to what? 0.12, or mu is equal to 12%. So you reject that claim, okay? You say it is not true. Did you get that? Hello.
Oh, it's not true.
It is not true because this calculated Z value, it falls in the rejection region, okay? Once you compare. If it was positive, this calculated value was positive, you could have checked this side. Obviously, it is still falling in the what? Rejection region, isn't it?
Yes, sir.
Is that clear?
Oh.
Hello, sir.
Yes, sir.
Okay, so the calculated value is 1.96 is greater than the Z value, then we reject, isn't it?
Yes, the Z value is falling in the rejection region. The location of this Z value, remember this is a number line from 0 here, coming this side, the negatives value are increasing. So this -4 is in this rejection region. Every point after this negative 1.96 is a fail to reject region up to this point. Okay, this region in here, this region you can't reject. It's a fail to reject region. For example, if this point, like this calculated value were maybe, let's say -1.20, it would have been somewhere here, right?
Yes.
This is the fail to reject region. You could have failed to reject the what? Null hypothesis. Did you get that?
Okay.
Yes, sir.
Yeah, you need to familiarize yourself with this. Yeah, even when you are done writing, not right now, but of course, you still meet more of this, especially that you're going to do research at 4th year. You will do more of this, like this testing of Chan. I really, you will do more this regressions of these things, like do more of that. So just equip yourself with that. Obviously, those that are going for postgraduate schools, again, you still have to do this. When you come back to do your studies again, you find that it's just much of research. So please acquaint yourself with this. Is that fair?
Fair enough, sir.
You can run away from it today, but it will still come in the future. Like it's still coming unless you stop school, but don't quit school. Okay, that was commercial break. We move on. Okay, now from here, any question? Is there any question? Hello. There is no question, sir.
When you use the Z value or the Z, what do you call it? The Z way of testing the hypothesis. Have to come up with a value so that you compare with the one that has been given in the question if it's true.
Sure.
So, okay, so after now you get the value, you keep it, then you go back again and do the null hypothesis where you check what the question is saying. If it's symmetrical, that means you divide it by 2.
Sure.
Okay. Then the value you find, you look for it in the chart.
Yeah.
And look for critical value. So if the critical value, if you find that your Z value is the one that falls in the rejection, that means the rejection region, that means you reject the null hypothesis.
Yeah.
Okay.
Okay.
Okay, sir.
Regression analysis now. Okay, let's do regression analysis, linear regression. Do I have a question? Do I have a question?
Sir, if the Z value was a single tail, how was it going to be?
Okay, if it was a single tail, your alpha could have been 0.05. So when you go to that table where you're looking for 0.025, you were just going to be looking for 0.050, right? You were going to be looking for this number, not for this one. You get it, right? You're going to look for this one because it has not been divided by 2. And then follow the same way of doing it, like same everything, same. You got that?
Yes, I got it.
Okay. 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 Here is the Excel output. Is the Excel output. The output from Excel for multiple regression model, analysis model. So what is there is there was a data. Let me read the question so that you can understand. I'll be quick on this one, but I just want you to. I'm sure you did this with the prof. That's what I heard. Is that true?
Yes, sir. But then I was suggesting maybe if we looked at one of these papers that he brought so that we can see how he brought the questions.
Okay.
Either the quiz or the test.
We were looking the questions from the quiz and still again, really these things, the way how they come, they are really just the same. Where is the 2020 statistics paper? Okay, I can't see. Okay, don't seem to. Okay. This was the test. I think this one was the test. So which one now? Like, okay, I literally have few of the things to talk about.
Question 6, sir. Question 6.
Question 6. This one?
Yes.
Okay. All right, fast forward. Let's do question number 6. The 2 in 10 marketing strategies randomly sampled are known to be ineffective in a banking sector. Can you calculate for the probability that...
Hello, sir.
Madam. We can hear you. Hello. Okay.
So which question are you is on the screen, please?
Question 6.
Hello?
Question 6.
Okay.
Somebody said question 6, so we are doing question 6 as said. So 2 in 10 marketing strategies randomly sampled. Madam, we can hear you. Hello, we can hear you.
Let's proceed, sir.
Okay.
Yeah, we'll proceed.
Okay. So now, so they are saying that 2 out of 10, right? 2 out of 10 marketing strategies that are randomly sampled are said to be what? They are known to be ineffective. Okay. So the probability, can you calculate the probability that if you sampled the sample size 6 marketing strategies in the banking sector, none of them will be ineffective. Okay, none of them will be ineffective. What probability distribution method is this one? Is it Poisson? Is it geometric? Is it binomial? Anybody? Okay. So, so the thing is that you are given the average. You are given on average the probability of getting what? An ineffective marketing strategy, which is 0. What? 0.2, right? Like 2 out of 10 is 0.2. Then you are given the sample size that somebody selected a sample size of how many strategies? 60 strategies. So the question is that out of the 60 sampled, what is the question that none of them will be what? Meaning 0 of them will be ineffective. So how you collect data, this data is following the binomial distribution, like you're using the binomial distribution, where the probability of the random variable x, when x is given as any the combinations of R. If you want, you can use x. That is equal to any the combinations of x, the probability to the power x times 1 minus the probability to the power n minus what? Minus x. So what you're trying to do here is that you're just, trying to compute into this formula for the binomial distribution. That's what you're trying to do. Your n is the sample size given as what? Your sample size is what? 6, right? Then the small x, this small x, like is the probability of success that you're looking for. So you are asking for the probability that there will be 0 success. Your success in this case is to get an ineffective marketing strategy. So what is the probability that you have 0 marketing strategy? So a small x will be 0 times what is the probability? The p value is 0.2. The probability for each independent trial that you get the ineffective is just 0.2 to the power 0 multiplied by what? 1 minus p 0.2 should be 0.8, isn't it? Like 1 minus 0.2 is 0.8 to the power n is 6 minus 0. You got it? And so from here,
no, sir. First, this is the n. First, describe the formula, sir.
Which is the sample size? The sample size, right? Then in this small x, x is the probability of success. The probability of success. Okay, whereas this p is the probability of success in each in a single independent trial. Like every time once you try, what is the probability that you get an ineffective marketing strategy? So in the question we are given that every time you try, you get the probability of what? 0.2, which is 2 over 10. You get it?
Yes, sir.
Yes. Then this 1 minus p, it is the difference 1 minus success.
X is written on top of the p.
Yes. This small x. It is this same probability of success. The x, the small x, that's same one. This n is the sample size, and this x is still the same x. Like everything still same.
Okay.
Yes. So we identified our data as our p equal to 0.2. 1 minus p.
Sorry.
Yes, sir.
Where is the 0.2 coming from?
Okay. 0.2 is given as the probability of success in each independent trial, right? Every time you try, it is given that 2 out of 10, 2 in 10 marketing strategies randomly sampled are known to be ineffective in a banking sector. So like this is what you're given that all the time you make a trial, at least you have a probability of 2 in 10, which is 2 out of what? 2 out of 10. That's the probability of success. What is your success? Your success in this case is to locate or find an ineffective strategy, marketing strategy, okay? So in each time you select it is given that you have the probability of 0.2 to select an ineffective strategy. Did you get that?
Copied.
Okay.
Yes, sir. Then 1 minus P.
1 minus P is basically 1 minus 0.2, which is 0.8.
Okay.
Sure. So what do? You just compute now into this. Now, listen, this one is called the what? Is the combination. This one is a combination. You don't, like, you know how you do combinations, isn't it? On your calculator. Just like the way how you did this one. I'm sure you did it in an exam, in your test. The way how you did
Sir,
this.
that's why I was even asking about those two.
Oh, okay. You go on your calculator. On your calculator, there is, if you're using cash, there is a button which shows like any CR like this. It is on the upper, is it upper left? Something you check on your calculator. That's for the combinations. So you just press 6, then you press that button. It will write C. Your calculator will write C like that. Then you write what? You write this number 0 here. It will give you the answer. Did you get it?
Yeah, again, sir.
Like just press 6, then you press that button. There is a button on your calculator that has got this.
Yes, sir.
That's for the combinations. Like just press that button, then you press this number down here. So first the number on top, then the number down.
No, sir, come again.
The number on top. Go where? Like on your calculator, that should be upper left if you're using cash or calculator, I think. There is a button that has got this, especially if your calculator has got, you can, the labels are visible enough. You should see the, okay. Is there anyone who is able to see what I'm talking about? Maybe I'm just talking.
Yes, sir. Me, I can see those ones. Then.
So how you press, you just press 6, then you press that C like this. Then you press this number down, 0. That's what I'm saying. I'm saying you press 6, then you press the button, and then you press this number down.
It's 1, sir.
That's the guide. What do you get?
Okay.
1.
1.
It's 1. Okay. Thank you. Then in this 0.2 to the power 0 again is what? It's still 1 as well, isn't it? Then times 0.8 to the power what? 6. What do you get? You know how to do
0.262.
0.26 what? 2. Right? Are we all finding the same thing?
Yes, sir.
Hello.
Yes, we found 0.262.
Okay. And so from there, we go to the other question. The other question says, what is the probability that more than half will be ineffective? Which means the probability of success will be more than half of the sample. Our sample is what? Is 6 now. More than half means what? Means more than 3, isn't it? It means more than 3. So that is for the probability that your small x will be what? Will be 4 ineffective strategies, 5 and what? And 6, isn't it? Like this is the Yes, they're more than half. That's for 4, for 5, and for what? For 6. So what you are trying to do, these are your x's now. You are trying to compute the same way how we are computing, but using these small, these different values. You'll be finding different answers. Those answers, you should add them together. That's the final answer. But it is not clear when you're just saying it. It's better we do it. That's when we will understand. Okay, we can do it fast, so that we can at least do something else. So what is our n? Our n remains 6. Our x now is what? 4, isn't it? Probability of success still remains 0.2 to the power 4 times 0.8 to the power 6 minus 4. Are you following? Hello.
Yes, sir.
Okay. What is 6 combinations of 4?
15.
Is what?
15.
15. Times what is 0.2 to the power 4?
1.006.
1.006 times what is 0.8 to the power, this should be 2, right? 6 minus 4 is 2. To the power 2.
So the answer here is 0.64.
0.64.
Yes,
Hello.
4.
Just that.
Yes.
Okay. Then you can multiply
Hello.
all of them together. Yes, sir.
0.2 to the power 4 is 0.0016.
Oh, it's 0.0016. 16. Okay. So when you combine everything together, what do you get? What do you get as a probability?
9.6576.
9.
I got 0.01536.
0.0191696.
0.2.
Yes, yes. My colleagues are correct.
0.01696.
696. Okay. That is for the first what? For the first one. You get it, eh? Let's pack this number somewhere.
Sir, I've got a question, sorry.
Yes, madam.
Where has the 4 come from?
Oh, like we are looking for the probability that the ineffective strategies will be more than 3. So the probability, they can either be 4, they can either be 5 or 6. You got that, right? So that's why we are computing for 4. We need to compute for 4, for 5, and for 6. You got that, right?
No,
So we are
sir,
computing.
someone's mic was on, so I was not getting what you were saying.
Okay. So we are saying that the question is asking that what is the probability that more than half are ineffective, right? Which means more than 3. You know, our half is what? Our half is 3. Okay. Our half is 3. So more than 3 are ineffective. So that is to say, for more than 3, we mean that they can either be 4 or 5 or 6. Okay. So these are X values, like our probabilities of success can either be 4 or 5 or 6. That's how we compute, that's how we find this 4 first. So first we start with 4, then the next one that we'll do with 5, then the next one we'll do with 6, then we'll add the answers. Did you get that?
Yes, sir. Thank you.
Okay. So this one is 0.01696. What about the next one? The next one, you are just changing here, you're just putting 5 here. And here where
Excuse me, sir.
Yes, madam.
How did we arrive at the final answer, which is 0.01696?
Sorry, just before you answer, my My calculations are giving me 0.01536.
Yes.
That's what is giving me as well.
You know, the problem is I'm just receiving the answers from you. So at
0.1536.
0.01536. Do we have anyone confirming to this? Like,
I affirm, sir.
Yes.
okay, all right. Then okay, that is the one that we will write then 0.01536. Then let's do the one for 5. We just change here where there was x, now we put 5. So you can do what is 6 combinations of 5? 6,5. Just do that.
6.
It's what?
6.
6.
I'm not getting, sir, sorry.
It's 6, sir. 6.
It's just 6. Okay.
Yes.
Okay, times the, what is 0.2 to the power 5?
Zero point 0.00032.
32 times what is, or times
0.8.
0.8?
It's 0.2. Yes.
Okay, now when you multiply everything, what do we get? For 5 now, that one.
0.001536. 36, yes.
Do we all affirm?
Yes, it's correct.
Okay. Then from here, you can do for 6, right? It means where there is 5 now, you just put what? 6. So when you put 6 here, even here will be 6. Here will be 6 minus 6, which will be what? 0. What do you get? What is 6 combinations of 6?
1.
1. What is 0.2 to the power 6?
6.4.
6. No. Is it 6? Is everyone finding 6?
It is 0.0064.
0.006 what?
0.64.
0.006.
And that's the final answer.
Then times what? Times 1. You know, 0.8 to the power 0 is 1. So once you just multiply everything by that, it will be 0.006 what? 0. Then you add these 3, okay? Just add these 3 here. Add the 3. Is that clear? You add the 3 and you'll be fine. Are you okay?
Yes, I'm getting 0.0552. 0.0552.
What about others? Are we getting the same thing? Are we getting the same thing? Hello. Am I logged out?
You're not. You're not.
Oh, okay.
Sir, what answer did they find?
0.101696.
Others, what did you find?
I found 0.02222896.
I'm finding different answers. Okay, can we confirm? Like, can we have others? Then we'll pick the majority. Just adding these three numbers one, like let's add them.
0.01536 plus
Hello.
Yes, sir.
0.0015.
The third answer, the probability for 6, it's not supposed to be 0.006. I'm getting 0.00004 zeros, then 64.
Yeah, me too.
Because when you find the combination of 6 and 6, it's 1. Then 0.8 is also to the power 0, which is 1 as well. So you just power 0.2 power 6, and it's giving 0.00064.
With how many decimals?
So there are 4 zeros before 6.
Yes, there are 4 zeros before 64.
Okay, so the final answer is 0.01696, not so.
Yes, that's what I found.
Yeah.
Yes, I also find the same.
Okay, checking out.
Just make sure you zeroize the calculators. There's a way of clearing everything so that they become 0. It depends with the calculator that you're using. I'm sure if you're using Casio, hello, if you're using Casio, there is where I think above there is where it says mode and clear. So you press shift, you press shift, then you press that same button, then it will bring, I think, 3 options. There's 1, 2, and 3. Then you press 3. It will bring reset all. Then you press equals. I'm sure it's brought the reset all. Then you press equals. It's bringing those to my dot lines. That means it's clearing everything. It's bringing the calculator to its normal function. Then you press equals again. Then it's reset all the settings.
Hello, sorry, kindly come again. What do you do after it brings the dots? After the calculator brings the dots?
Yeah, you press equals again.
Sorry, I've been kicked out by the network. And okay. Oh, it was this one. Okay, yeah. So at what way are you finding?
The final answer is 0.00000, 4 zeros, then 64.
Okay. All right.
That is for the probability for 6.
Oh, that is just for 6.
When you power it, yeah, to the power 6. Then when we add all these, somebody gave the answer. I'm not sure who gave the answer.
What is the answer?
The answer is 0.01696.
Like this.
Yes.
Okay, what is more important is not really to memorize answers, it's to know what to do. Obviously, if we have known what to do, then we are good to go. Can we find the expected value, the mean, for this? Is just found by NP, isn't it? What is our N? 6 times 0. What? 2. What do we get?
1.2.
1.2. So what's the standard deviation? What is the standard deviation?
0.96. Sorry, no.
How do you get it?
So it's 0.9797979.
0.979.
97, again 9.
Are you agreeing?
Yes.
Okay.